Hey there, folks. So, for the observant of you, you may, well, I'll tell from the episode's title, but you can see we are going to start work on the equipment system again. Excuse me. Now, so I have gone through and I've spent a long time trying to figure out how I wanted to move forward. Things like the number of equipment slots I wanted to deal with, the number, like, can you have 3 different shirts? For anyone who's familiar, you've got games like Project Zomboid and Neo Scavenger, where your level of equipable items is fairly extensive. And those items, well, and that, so I should say, that extensive system is something I would love to implement. One of the big differences, though, for me at least, it's trying to find that happy medium between the level of complexity that I want for this game, which is, like I've said in the past, I'm trying to develop something that's as close to being realistic survival simulator as possible. Obviously, simulating real life in a game is incredibly hard to do and also incredibly complex. And for the player, it's likely going to get incredibly tedious. But anyways, before I get into a huge monologue about that, as I was saying, I've been spending quite some time trying to figure out just how I wanted to do this, what slots I wanted, things like that. And I'll be honest, I still haven't figured that out. But instead of being held back by that, what I've done is I've sort of planned out, sketched out, gray box, whatever you want to call it, some concepts and ideas for a way that I could implement the equipment system in so that it's expandable in the future. So you can see I got a lot of different stuff open here, but like right now we've got generic, what was 1, 2, 3, 4, 5, 6, 7, technically 6, because we don't want to use this one for the clothing, but we've got 7 equipment slots, and then there's obviously a lot more that can be added. I've commented out ones I had tried to add. But I want to basically do this in a way where you can expand this list, and it, within reason, you won't have to refactor much code. Now, how I wanted to do that and how I've gray boxed that out, it's actually here in our equip item at index function. This is a starting point. We've got 2 different ones here. I've added the code comment for it. Drop stack at index. Excuse me. This is also if like they're wearing it when they drop it. And in here, this is going to be where we expand the code. So, anyways, to get started in there, the first thing we're going to want to do is sort of plan out some rough code that we're going to implement for this. So I've gone through, and I know this episode is going to be a little different than normal, well, than the last few at least, because for anyone who's been following along, I've been trying to get this solution, or come to a solution for this for a couple months now. And I've got quite a bit of this documented on paper now. So initially, what this is going to be is our inventory component is going to cast a callback to the owner. The owner is then going to cast a callback to the stat line. And the reason being for this, where's my stat line header? Do I not have it open? There it is. It's our stat line that's holding, well, some of the information. Our heat insulation, our cold insulation. I don't think we've added in protection. check. Yeah, no, we haven't added in the protection values for that. So what we're going to be adding in here, I believe I've already got some of these. Yeah, adjust heat insulation, adjust body coverage, set building insulation. We're going to need to add in some additional functions here. So we're going to start off in our statline component. So we're going to add in void add, actually, we're not going to start right there. We're going to start in our equipable item base, and we're going to see, oh no, clothing item base, that's the one we want. We have piercing, bludgeon, and slashing on top of our 2 insulation. So back to our stat line, void add, sorry, not add, adjust, piercing, protection, const float reference amount. And I'm just going to copy this and I'm going to rename it. Piercing, adjust, bludgeon, slashing. Now these are, again, just going to be the 3 functions we're going to have to call back to our stats. Do we have a region for this yet? Temperature, movement, complex needs, stats. We will add that to the stats section. Do we have a visible in here? Yeah, there we go. Nope, not delete. And copy. We're going to change this from the stats group to, let me get rid of that find, protection. And I'm actually going to do this to the, and no, I'll leave that in the temperature. No, I'm going to do that to the temperature as well. Visible anywhere, blueprint read only, category, stat line protection, save game. I'm not sure if this is going to be needed because, yeah, no. No, I'm going to add in functionality to recalc that on load. Current X protection, and I'm just doing this for the sake that we're going to copy this. So float piercing not B piercing protection equals 0. Float bludgeon protection equals 0, and finally float slashing protection equals 0. And I didn't copy the whole thing, but piercing protection, I'm going to change this to blunt protection and slashing protection. So now that we've got that, let's go down, create these definitions. Now this is something you'll want to think about in your game as well. Do you want to have, trying to think how to word this, damage types that a creature is more susceptible to? So like, I'm thinking fantasy RPG vampires are more susceptible to piercing damage because you have a better chance like stabbing him in the heart. I know that doesn't really work out, but that's a good example, at least for what I'm trying to convey here. If you want to be able to have more susceptible, you can have the protection value be able to drop below 0. If you don't want that, which is how I want to implement this, I do not want protection values to be lower than 0. You're going to want to implement it in the way I'm about to. So, piercing protection equals fmath clamp. Helps if I actually typed it. Clamp piercing protection plus amount, minimum of 0, and then you're going to want to have your max value. In my case, I'm going to set it to 1 for now. Do I want to set it for 1? Do I have access to a character? Yeah, the character defines. No, I'm going to add a define for this actually, just because. Define max protection value. And right now, it's going to be 1. But for purposes of things in the future, this allows you to tweak that easily. I know I've explained that before, the use of a define instead of a hard-coded value. So this is pretty simple here. I'm going to copy these over quick, and this is bludgeon. I'm not sure if I've spelt this right. Oh, no, I haven't. Okay, let me just Google search this quick. I can't remember how to spell bludgeon. It is D. Okay, so this is wrong. That is the correct spelling. B-L-U-D-G-E-O-N. B-L-U-D-G. Alright, so let me just fix these. So, bludgeon protection. Bludgeon protection. Okay, in our header file. Bludgeon protection. Alright. No, we didn't name fix the stat either. Alright, so now we've got that in there. Bludgeon protection. You just want to do the same thing. Now, this is something I've done in the past where I copy-pasted things and I've made mistakes. That is something you want to be very careful with. I'm actually going to fix something with that probably in the next episode. But because I finally decided how I wanted to move forward with the equipment, I've decided get this out of the way because it's been one of those things that's been sitting for a while. So anyway, slashing protection. When you copy and paste stuff like from function to function, be very cognizant, paying attention to what values are being used. So now that we've got that, we have these functions in for adjusting. We're going to want to also add in some functions for returning these values. These are going to be pretty simple. I'm going to scroll down. Actually, I'm going to add a region in here. Pragma region protection. Pragma and region. Void. No, these aren't voids. These are floats. Get piercing protection. Const. Float. Get bludgeon protection. Can't spell float right apparently. Const. And float get slashing protection. Now these three we're going to want to expose to blueprints. The reason being is if, as I've mentioned in the past, you need to consider modding support. If you're not worried about modding support, you don't have to expose these to blueprints. But again, it's nice to have them because then if you have a game designer, like if you're working on a team and you have a game designer, most game designers have some, from what I've dug into, have some basic understanding of code, but they prefer to, well, they're not proficient with code. They tend to work in blueprints. They do rapid design and stuff there. Everything I've read into, obviously never having done a game development job professionally, they sort of do conceptualization and then it gets handed over to a developer to implement properly. But adding these in quickly, we're going to go through quick action and just create all of these. Now, you could do these in the header file. I do prefer not using header-based function declarations. Sorry, definitions, not declarations, but that is going to be up to you. Return piercing protection. Return bludgeoning protection. There we go. And return slashing. All right, so that is setting up the basic functionality within the statline component. Next, we're going to want to deal with this in the character. So that's our TF character. Open up our base class here, TF character. And this is going to be a pass-through, for lack of a better term. And the reason being for that, to try and explain, is our inventory component is going to be used to handle equipment and everything like that. It only needs to know, well, not that it only needs to know, I'm trying to limit so that it only knows about the character that is its parent. I don't want our inventory component to know about all the stat line stuff. It doesn't need to. That's adding in levels of complexity with multiple, I'm trying to think how to word this, knowing about multiple endpoints, for lack of a better term, where if you have it so the inventory component only needs to know and only knows about the owning character, and it talks to the owning character, yes, you are adding some degree of inefficiency with that, but you're not worrying about code complexity. I hopefully explain that in a way that makes sense. It's a little difficult on my side, but anyway, so in here we're going to need to add in our character class some functionality for that. So let's see, public section down here, because it needs to be exposed to other classes. Pragma region protection, and pragma end region. We're going to have void adjust piercing protection const float. I cannot type today. Const float reference amount. I'm going to copy and paste these because I screwed these up before. Actually, I'm just going to copy and paste all of them. Problem solved. And these ones as well. All right, so now that we've got that, obviously same as before, we're going to create these references quickly, or create these definitions. Let me just get these out of the way quick. All right, so these are going to be pretty simple to start with. So we're going to say return stat line, get piercing. Copy up to the hyphen. It makes it a little easier. Get bludgeon protection. Get slashing protection. All right, so that is just exposing those via the character class. Now with these, again, it's pretty simple. These are just going to be stat line, adjust, piercing protection, amount, stat line, adjust, bludgeoning protection, amount, and you guessed it, stat line, adjust sloshing protection amount. Now, that's the basic stuff out of the way. The big one that's going to be involved here is going to be with our inventory component. So let me clear up some of this stuff here. I probably wanted to keep that open, but with that, don't need the message manager. Stat line component we don't need. Let me just close out all of these that aren't needed right now. So in our inventory component, this is where we're actually going to be doing a bit of code changing, because right here we're creating a cast reference that we're not storing long enough to reuse it. So we're going to go ATF character pointer P owner as char equals cast ATF character owner. Because what are you? Actually, it's just an A actor. Now, if P, I'm going to fix the spelling here. Owner, if P owner as character equals to a null pointer, log error, return. This is something that technically could go wrong here and cause because even though we've got this check here for it, there is a case where the cast fails. I have never had it, but you could have that fail. This should catch it, but find all references. I just want to take a look at that. So in here in our begin play, we're trying to go through and determining if it's a TF actor or a TF character. In theory, this should never fail us, and this should be perfectly fine. Well, this method should be perfectly fine. But it's one of those cases of, well, maybe it's better to have this added level of protection just in case. So now that we've done this, though, we can go P owner as character. We don't need this cast. Next thing we need to do, though, is right here we have our equipable item base, but we need to see if it's a clothing item. So if new clothing item base pointer as clothing equals cast u clothing item base as equip item, well, we have an unknown identifier. That's because up here we just have equipable item base. We could just add in clothing item, but our clothing item header includes equipable. So we just need to take that one step further up in that inheritance tree. And it's just clothing item. So if it is a clothing item, okay, well, we're good there. We know it's a clothing item. This was successful. P owner as character, adjust piercing protection. Now this is where, as much as I dislike complex code, it's sort of needed. be equip, we need to know if we're adding it, we want it to be as clothing. Get piercing protection. Otherwise, it's 0 minus. Now, this can be simplified. You could expand this to be... what are you complaining about there? Expected a... Oh, yeah, I got the wrong value there. I'm trying to think. Do we want to add the complexity here or within the function? No, I'm going to leave it as this. So the next one we're going to do is P owner as character. Adjust bludgeon. And then actually I'm going to go P owner as character. Adjust slashing. Now, copy and paste. And as I just mentioned, this, you need to be careful when doing this. Get pierce, sorry, this is bludgeon. And then get slashing. Now, to explain the reason for the 0 minus, I know I didn't actually say that when I mentioned first added it. So the way this works and the way this function has been set up, we have a const bool coming in saying be equipped, and that is being used for, are we equipping the item or are we removing the item? And that's so we just have one function here that is used for both. You could, if you wanted to, have two separate functions: equip item, remove item. With that being our way of knowing we're adding it or taking it off, we're using that down here. So if we're adding it, we want to increase our protection. If we're removing it, we want to decrease our protection, which is why it's 0 minus. This will result in a negative number being passed through so that it reduces the amount. Did we add those into the P owner as character cold? We never added our installation functions. So, but this method here anyways, we're hitting the 30-minute mark, so I'm going to end this episode off here. This is going to be a multi-part process. So, because we also have to, factor in changes to our inventory screen and stuff like that, which that I'm really reluctant to deal with right now. But anyway, so I'm going to end things off here, but just to explain this method that we've gone through, we have our inventory component, which is calling back to our character using the functions we added for adjusting piercing and bludgeoning slashing protection, which they themselves, let's go to definition, they are just a pass-through function to go to the stat line. The stat line, we are adjusting the various different protections based on the amount coming in. And for anyone wondering who's not sure, let's say 0.5 plus negative 0.5 will equal 0. So we're not worried there about how, like the fact that this is a plus. It will work for both adding and removing. We've got it set to a minimum of 0, and we do have a maximum value. I'm actually going to run a quick build while I finish talking here. And the reason for that being is I want to cap that. I haven't quite decided what I want to cap that at yet, but for now, I'm going to cap it at 1. It may be something I decide, okay, cap it at 10, cap it at 100. If it's 100, that would be for a percentile, and we can just use a float range from 0 to 1. So wouldn't need to go that far. But ultimately, the whole reason for that, though, is so there is a definitive cap. You don't want someone to have, and actually that reminds me, I want to fix that, 100% protection. Well, no, you might want people to have be able to have 100% protection, completely immune. So no, I'm going to leave that at 1 for this. But anyway, so that calls back to the stat line component. Let me save that tab, which we just adjust those. We add in the functionality to return those protection values. We need to add in quickly, I'll do that while this builds actually, U function blueprint callable. There is no space and no capital L. No, what are you complaining about? What failed? One build failed. What failed? Must return. Oh, yeah, sorry. Mistake on my part here. We're returning without actually passing in a return value of false. Now, right now, these all return false. We're not actually using that logic yet. What this should be is right here. Actually, we'll fix that return true. Okay, let's try and rebuild this anyways while I fix that other stuff. Float set cold adjust cold insulation. That's not a float, that's a void. Const float reference amount. Quickly just create that definition so we can do a build, and then I'll finish talking. But anyway, so with that, we've gone through, we've started the process of also adding in the logic for the cold and heat protection that an article of clothing adds. And from that, we are pretty close to having a functional equipment system, which will get things to a point there where I'm happy to sort of like advance the project a little further. This has been a real holdup for me because I wanted to get at least some equipment functionality in place before trying to move things any further. Just simply because, as I've mentioned in other episodes, having a foundation to work from is the best way to go about things. And having a basic equipment system working is something I would consider foundational. So, okay, so that build worked. So now we've got that. I'm just going to quickly add in the adjust heat, and we'll finish this off before I end the episode, instead of ending in the middle of something. All right, just heat. Create the definition. Okay, so in here, stat line. Adjust cold insulation amount, a stat line, adjust heat insulation amount. Now you could, and this is something I will probably do when it comes to refactoring, just simply because we have just added in what, 1, 2, 3, 4, 5. Well, technically more than 5, but we've added in 5 functions that are all doing the same core functionality. It is taking a piece of information from a clothing item and pushing it through to the stat line component. For the sake of moving the project forward, I'm not going to refactor this now, but one of the things we could easily do is change these from being a specific property adjustment to a function, let's say, adjust stats based on from clothing. And we would pass through a reference to the clothing item and a Boolean value of adding equipping or unequipping. And what we would do there is, instead of having all of these, it would just be P owner as character, adjust for clothing, be equip as clothing item. You pass those two variables in, and then all the way back in our stat line component, we'll have a function for parsing the information from the clothing. That is one thing you could do, and that is a way I probably could have done this. But at the same time, trying to keep the number of other classes that something is aware of, and that's what your includes are, trying to keep those as small as possible helps with code compilation. So, but anyways, folks, as I said, I'm not going to do that refactoring now, and I am going to end the episode off here. Actually, no, sorry. Let me just get these in, just heat, insulation. So these are going to be, I'm going to just copy this one here. It is going to be get cold insulation. So I don't want to leave these half done. Anyways, all right, so now that those are done, like I said, I'm going to end things off here. Next episode, we're going to continue this a little further. We're going to go through and see how this affects the character. I'm not quite sure how I'm going to handle the UI side of things yet, simply because I don't have well, I'm not an artist. Simple as that. But something I'm going to also start doing is at the end of episodes, I want to try and fire off a build just to make sure the code is working. There's been a couple of episodes I've done that I didn't do that, and subsequent episodes the build failed. But anyways, folks, before I keep getting distracted and this turns into a 2-hour episode, I am going to end things off here. As always, thanks for watching. If you have any comments, questions, suggestions, concerns, please feel free to leave them in the comments below. Hop over onto Discord. Ask your questions there. I do try to respond as often as I can. But as always, thanks for watching, and I will see you in the next episode.